Question: differentiate with respect to x. Sin log x y is equal to sin log x dy by dx. Now this is composite function. Suppose for y this is x. So sin x derivative is cos x. X means log x into multiply by derivative of log x, which is 1 upon x. So answer is cos log x upon x. Next question, e raised to root x y equal to e raised to root x dy by dx is equal to, suppose for y this is x, so e raised to x derivative is e raised to x, but x is this root x, so root x multiply by derivative of root x, which is 1 upon 2 root x, multiply by derivative of root x, which is 1 upon 2 root x. In the numerator e raised to root x, in the denominator 2 root x. This is the answer, e raised to root x upon 2 root x. Y is equal to root minus root x. Y is equal to root 2 minus root x. So dy by dx is equal to, suppose this is x, so root x derivative is 1 upon 2 root x, 1 upon 2 root x is this total value, 2 minus root x, multiply by derivative of this total value, derivative of this is 0, minus derivative of this root x is 1 upon 2 root x, is equal to, now this is 0 minus 1 upon 2 root x is only minus 2 root x. So in the numerator 1 negative sign due to product, in the denominator 2 into 2 is 4, root 2 minus root x into remaining this root x. This is the answer, minus 1 upon 4 root x, root 2 minus root x, root 2 minus root x. Next question, log cos x cube minus 3 y is equal to log cos x cube minus 3 derivative dy by dx is equal to, suppose this total value is x, so function is log x, derivative is 1 upon x, 1 upon this total value which is x, cos x cube minus 3 multiply by derivative of this value, but this is again composite function, so suppose this value is x, so cos x, derivative of which is minus sin x, x is x cube minus 3. Sin cos this value is minus sin this value, again multiply by derivative of this value, derivative of this is 3x square minus 0. So minus sign is there in the numerator, 3x square sin x cube minus 3 upon cos x cube minus 3, which is tan x cube minus 3. Answer is minus 3x square tan x cube minus 3. X cube minus 3, x cube minus 3, x cube minus 3. Minus 3x square tan x cube minus 3. This is the answer. Next is log tan x by 2. Differentiate with respect to x, log tan x by 2. Take y is equal to log tan x by 2 dy by dx. Suppose for while this value is x, log x, that means derivative is 1 upon x tan x by 2 into derivative of this function, but this is again composite function, tan x by 2, suppose this is x, tan x derivative is sec square x, so sec square x by 2 multiply by derivative of this value, derivative of this value is 1/2, outside derivative of x is 1, so 1/2, derivative of this value is 1/2, outside derivative of x is 1, so finally it is 1, derivative, finally it is 1/2, derivative is 1/2. Is equal to 1 upon tan x by 2 is cot x by 2, that means cos x by 2 upon sin x by 2, sec square x by 2 means 1 upon cos square x by 2, sec square x by 2, 1 upon cos square x by 2, that means cos x by 2 into cos x by 2 and this is 1/2. Cos x by 2, numerator 1, in the denominator 2, sin x by 2 into cos x by 2. X plus root x square plus a square, root x square plus a square minus x, y equal to log x plus root x square plus a square, root x square plus a square minus x. Now start y is equal to log. In such types of problems we have to take complex conjugate of denominator and multiply and divide. In this way, write first this term x multiply and divide by complex conjugate of denominator. Complex conjugate of denominator is root. Multiply by complex conjugate of denominator. Complex conjugate is root x square plus a square plus x. Multiply and divide by that term x square plus a square plus x. Take here brackets. Suppose this term is m. So here is m into this term is also m. So m into m is m square. So m square, that means square of this. So x plus root x square plus a square bracket square is there. See once again. Suppose this term is m. This is the same term. M into m is m square. So what is m term is right here and square is here. Suppose this root is n and this term is n. Then this is m minus n and this is m plus n. So product is n square. That means square of this term. Minus we take square of this term which is x square. Now x square get cancelled. Y is equal. So y is equal to, now we use logarithmic rules. Log m raised to n is n log n. So 2 log x plus root x square plus a square. Here at denominator there is a square, so we take minus log a square according to logarithmic rule. This log this term upon this, but log m raised to n, so 2 log this term minus log a square. Now take derivative. dy by dx is equal to, here is constant and log function is there, so constant as it is. Derivative of log this term, suppose x, log x derivative is 1 upon x, 1 upon this term into derivative of this term, take derivatives respectively. Derivative of x is 1 plus derivative of this root term is 1 upon 2 root x square plus a square. Again derivative of this term x square derivative is 2x. Always remember d dx of x square is 2x. So derivative of x square is 2x plus derivative of this constant is 0. So 0 don't write in this way. See once again, 2 log x, 1 upon x, derivative of this is x, this term is there, x derivative 1 plus derivative of this term 1 upon 2 root x square plus a square. Also derivative of this x square plus a square is derivative of x square is 2x plus derivative of a square is 0. So 2x plus 0 is 2x. In the numerator 2 x plus root x square plus a square into 1 plus these 2 and 2 get cancelled, x root x square plus a square. Now here there is sum of two quotients, sum of two fractions. So for solving this, write here 1. Sum of two fractions. For solving this, write here 1. Now cross product at numerator, so root x square plus a square plus x, product at denominator, root x square plus a square if we see then which is this term is term here, x plus root this term, x plus root this term. So in the numerator and denominator get cancelled. Final answer 2 root x square plus a square. Question: if fx is equal to g 3g 5 gx g0 equal to 0, g dash 0 3, find f dash 0. Fx is equal to g 3g 5gx f dash x, that means we have to take your derivative. Derivative of this side is f dash x, derivative of this side is d dx g 3g 5gx derivative of g 3g 5g x in this way. F dash x is equal to d dx of g 3g 5g x is equal to d dx of g, this function, that means g dash, this value 3g 5g x into 3 into derivative of this term. While taking this derivative, take 3 outside, 3 d dx of g 5 gx fx is this term, f dash x is d dx of this term, d dx of this term, that means g dash, this term, into derivative of this, but while taking derivative, constant is 3, take outside derivative of g 5 gx. Next is equal to g dash 3g 5gx 3 d dx of g, this term is g dash of this term 5 gx into d dx of this term, so 5 take outside, d dx of gx, this term as it is, 3 into derivative of this term g dash, this term, to d dx of this term, 5 take outside, d dx of gx, g dash 3g. Now this is 3 and this is 5. We take their product is equal to 15. G dash 3g 5gx g dash 5gx d dx of gx is d dash x. Now put x is equal to 0 is equal to 15 g dash 3 g 5 g x is 0 g dash 5 g x is 0 g dash x is 0. Look at this term. G0 is 0. So if we put 0 here, this is product is 5 into 0. So this term is 0. So 15g dash 3g. Again see g0 is 0. So 0 into 5 is 0. So g into 0. G dash. G0 is 0. So 5 into 0 is 0. g dash 0. Put all the values. 15 g dash 3, g0 is 0, g dash 0 is 3, again g dash 0 is 3. 15, this is 0, so g dash 0, and this is 9. 15, g dash 0 is 3 into 9. This product is 405. This is the answer. See this step. Take y is equal to e raised to log x bracket square minus log x square. There is rule in the logarithms. Rule is e raised to log m, value is m. So here is e raised to log, suppose this is m, so we take value m. M means this log x bracket square minus log x square, which is only value of y. Next we have to take derivative respectively. So dy by dx is equal to, now this is x raised to n rule, 2 log x multiply by derivative of log x, which is 1 upon x. Here we get value of y is this. Next step is take derivative dy by dx. Derivative of this term according to x raised to n rule, 2 log x. Again we have to multiply by derivative of log x, which is 1 upon x. Then minus log x square, derivative is 1 upon x square, into derivative of x square is always 2x. Log x square, composite function, derivative 1 upon x square, again multiply by derivative of x square, which is 2x. In the numerator 2 log x, denominator x, in the numerator x get cancelled, minus 2 upon x. This is the answer. 2 log x upon x minus 2. Sin square x square minus cos square x square. Y is equal to sin square x square minus cos square x square. Dy by dx is equal to sin square x square, derivative is x raised to n rule, 2 sin x square into derivative of sin x is cos x, that means here cos x square into derivative of x square is 2x minus cos square x square, derivative is 2 cos x square, 2 cos raised to 1 x square. Cos x square derivative minus sin x square, derivative of x square is 2x. So 2 sin square 2 sin x square cos x square 2x minus into minus plus 2 cos x square sin x square into 2x. If we see then 2 sin x square 2 sin x square cos x square. This term is common. 2 sin x square cos x square. 2 sin x square cos x square common, remaining term 2x. This term is common, sign is plus, here is 2x. Now this is, suppose this x square is theta, so this is 2 sin theta cos theta, this is 4x. Sin theta cos theta is sin 2 theta. (4x), but theta is x square. For this x square we write theta. So 2 sin theta cos theta, 2x plus 2x is 4x. 2 sin theta cos theta is formula sin 2 theta. This is 4x. Sin 2 theta is x square, 4x. And this is the final answer. Sin 2x square, 4x.